Okay, so this one, we have to do all these transformations, use different colors to represent or numbers to show the graph below. So the first thing I'm going to do is graph the parent function, which is log base 5 of x. So when graphing the parent function, I know I'm going to have the point 1, comma 0, and then base, comma 1. So this is the graph, and I'll call this number 1 of log base 5 of x. There is a vertical asymptote here, which is the y-axis, and those are my two anchor points that I'm going to use. Okay, so graph number 2 is going to be f of x equals the negative of log base 5 of x. If the negative is on the outside of my function, it's going to take a reflection over the x-axis. So that point stays there. This point comes down here. And I have this graph right here, and this is the graph for number 2. Okay, for number 3, I'm going to have f of x equals the negative log base 5 of x minus 1. The minus 1 on the inside of my parentheses moves my graph 1 unit to the right. So this point gets moved over here, which will do like a little square, and this point gets moved over there, which will do a little square. And that means that my asymptote also gets moved to the right. So I'm having this graph that looks kind of like that, and that's number 3. And finally, number 4, which I'll do in a different color so we can totally see it all together, is going to be f of x. Oh, it's too big. So let's go 1 point. So the f of x is going to be the negative log base 5 of x minus 1, and then finally up 3 units. So each of my last points from number 3 gets moved up 3 units. So 1, 2, 3. So I'd have this point here, which looks like it, and then I'd have 1, 2, 3. I'd have that point there. So the point that we're looking for there is 2, comma 3, and the point over here looks like 6, comma 2. So I still have my vertical asymptote there, so I'd cruise down like that, and that would be the graph that I'd be looking for. You could check this in the calculator to see that that is exactly the graph that you need.